Hey guys, let me make sure this mic. Yeah. Okay. So today, or I had this session earlier, but I'm just gonna go ahead and go over the back of the worksheet that I didn't get a chance to get to today. So let me just set this up. Okay, so this portion of the worksheet is over neutralization reaction. So what is another name for a neutralization reaction? What are we trying to neutralize? What are we using to neutralize it? So another name for this type of reaction is going to be an acid-base reaction. So based off of the fact that it's an acid-base reaction, what are the two reactants of the neutralization reaction? Remember, the reactants are on the left. So our two reactants are going to be an acid plus a base. Typically, these bases are going to be in the form of a metal hydroxide. And this sounds kind of scary, but all it means is that it's going to be a metal paired with the hydroxide ion. Remember, the hydroxide ion is OH minus. So you're going to mix that with any type of metal. So what are the two products of a neutralization reaction? So first off, let me back up. So an acid is characterized by an H at the front, and a base is characterized by an OH at the end. So stick with me here. Our two products for a neutralization reaction are going to be water plus a salt. A salt. So the reason it's going to be a salt is because it's going to be an H attached to an anion, right? And here, our cation is a metal, and that's going to join. So a salt is a non-metal, a metal plus a non-metal, and that's what we're going to get from this type of reaction. We're also going to get water. So you can write water two ways. We're pretty used to H2O, right? But if you see here, we can get HOH, and it's the exact same thing. Okay, what is the net ionic product of a neutralization reaction? So let's back up and think, what is a net ionic product in the first place? So it's going to be when we have things reacting in aqueous solutions, they're going to react, and we're going to typically, we learned about this in the format of you're going to get a precipitate or a solid, but it doesn't have to be a solid, it just has to not be aqueous. The net ionic product is always going to be water. So why is it water? Well, let's think. What does aqueous mean? If something is aqueous, what does that mean? It means it's dissolved in water, right? Can water be dissolved in water? No, it's just more water. So water is a liquid. It's not aqueous. And whenever there's a change in that state of matter, that is your net ionic product. Okay, write the complete molecular formula for reaction of hydrobromic acid and lithium hydroxide. Okay, whoa. So let's sort of break this down. We're going to have to go back and remember how to write formulas, right? So hydrobromic acid. When we're talking about acids and we have this hydro in front, that means we're working with a binary acid. That means there's only two elements present. Bromic, brome is the root word for bromide. So we're going to have HBr, aqueous, plus lithium hydroxide. So hydroxide is going to show up a lot. So it's one of those polyatomic ions that you're really going to want to learn. So lithium hydroxide is going to look like this. So what's it going to afford? So this is a metathesis reaction, right? We're trading partners here. So we're going to end up with a salt, which is a metal and a non-metal, right? Lithium is a metal. Bromide is a non-metal. We have lithium bromide. And according to your solubility rules, this should be aqueous. Plus HOH, or you can write H2O. HOH and H2O are the exact same thing. It's personal preference, and atoms will know what you're talking about, whichever one you write. So this isn't aqueous. It's not water dissolved in water. It's just water. It's a liquid. So after you write out a formula reaction, the next thing you want to do is make sure that it's balanced. And this is, we have 1 bromine, 1 lithium, 1 hydrogen, 1 hydroxide, right? Write the complete net ionic formula. So the key here is this word ionic, right? We're breaking things up into ions because when something is aqueous, when it is dissolved in water, it's really just those ions floating around inside the water, right? So we're going to have H plus, and if you're wondering where I'm grabbing all of these charges from or why there are no subscripts down here, remember to look on your periodic table to get the charges for these. For hydroxide, that's part of the polyatomic ion. It's going to be on your list of polyatomic ions. And because they're all one, I'll let you know now that they're all one. When you swap and drop, they cancel out. You don't have to put H1Br1. So we're going to have H plus aqueous plus Br minus aqueous plus lithium plus aqueous plus OH minus aqueous. And yes, you do have to put the charges for all of them. Yes, you do have to write aqueous or the state of matter for all of them. Goes to lithium plus aqueous plus Br minus aqueous plus HOH liquid. So that's your complete ionic formula. Complete meaning you're writing down every single thing that's in that molecular formula. So write the net ionic formula. Net means we're only focused on what's reacting. We're focused on what's forming something new, right? So the way that we're going to figure this out is we're going to cross out what's the same on both sides. So this is just me. I like to draw a line at the arrow, otherwise I'll get confused and start looking all over the place. So we have a hydrogen ion here. We do not have a hydrogen ion over here, aqueous. Bromine, got that. Lithium, on the sides, hydroxide, no. So that means our net ionic equation is just everything that we didn't cross out. So it's H plus aqueous plus OH minus aqueous goes to HOH or H2O, again, whatever you're comfortable with, liquid. And that's all there is to that. So remember my email is on my website. You can always email me if you have any questions. You can message me through the Remind, or you can submit a contact form if you scroll all the way down to the bottom of my website. I will see all of those. I will respond to all of those. And also don't forget that if you're struggling right now, that's totally okay. This class is super fast paced. So if you feel like you need more help than just SI, it's totally worth it to go to the tutoring center and set up a tutoring appointment for this class. Okay, I'll see you guys next time.